So we're going to continue the conversation of tools and resources to bring into your work, of inserting climate into the weather. And one of the areas where we've seen such growth in the science is attribution science. Now, many of you have been here since the beginning of us bringing this to this forum. However, not all of you have. So I want to ground this conversation for everybody that attribution science is a part of climate science where you can go into individual weather events and assess the role of climate within that event. So it's really fascinating science that has changed dramatically over the past 20 years, even since the last time we came to talk to you about it. So what we're going to do today is divide this afternoon into two parts. The first part, we're gonna update the science, where we are, why it's important, and tools to bring that into your work. And then the second half of today, we'll have a break, we're gonna have Leo leading a workshop because World Weather Attribution has a reporting guide right now for journalists, but we want to adapt that reporting guide to TV weather presenters. So we're gonna use you and your information and your knowledge to help update that reporting guide. So that's how we're gonna play out today. It doesn't have to be super formal. We're going to try and reserve a lot of time for questions also, but we're going to go through each three of our speakers first before we get to the first round of questions. So you could just jot them down if it's from the first speaker. So joining us today, we have got Mariam ZACHARIAH from the World Weather Attribution. We have Julie Arrighi, who's the acting director at Red Cross Red Crescent Climate Center. And we have Andrew Pershing, who's my colleague at Climate Central. He's our VP of Science. So starting it out, we've got Mariam.
Can I go down? Hello, everyone. I'm Mariam ZACHARIAH. I am part of the World Weather Attribution team, and I work at the Grantham Institute for Climate Change and the Environment at Imperial College London. So as I was saying, I work as part of an incredible group of people, and we are a group of scientists. We have people from the social sciences domain, and we have our amazing comms team as well. And this is a picture that got taken back in June here in France. And these are the places that we are based out of. And to say in a nutshell, what we do in World Weather Attribution is we take up recent extreme events that have been impactful, that have had a lot of impacts, and then we quantify, we analyze if whether and to what extent did climate change influence the chances and the magnitude of the extreme event. And by extreme events, we mean that includes heat waves, cold extremes, droughts, extreme rainfall, and yes. So we know that we have been putting fossil fuels into the atmosphere since the pre-industrial times, from the mid-1800s. And as a consequence, we are witnessing the global mean surface temperature trends going up. And along with the global temperatures, it also affects the trends in the extreme events. And when I joined my PhD back in 2016, attribution science was still, about 7 or 8 years old. It was relatively new. And this was the analogy that was given to me, or this was the analogy that I used to hear all the time. So, in a world without climate change, we can assume it to be like your dice. And you roll it, the probability of getting a 6 is 1 out of 6. And then now you imagine that the die has been loaded so that, every time you roll, there are more chances of, it rolling a 6. So attribution is like that. So when you look at, the observed trends in these variables, we find that the trends cannot be explained by a climate that is not warmed by us. because of the fossil fuels. And it is on this foundation that the attribution, extreme event attribution also works. So when you look at a climate variable, let's say it used to follow a distribution, and then because of of global warming, it now follows a different distribution. So let's say a temperature that we saw a couple of days ago. In a climate in the past, let's say the chances of it was something, and now it is a different something. And this ratio helps us to quantify how much more or less likely has the event become due to climate change. Now, at World Weather Attribution, we try to do these studies rapidly. So the understanding here is that because we have to do this in a time frame so that we can inform people and inform the stakeholders about what prompted the event, what were the factors that contributed to the event that we saw, and what needs to be done. So we cannot do that if we have to do a study and then try and push it through peer review every time. So what we have is a protocol that has been peer reviewed, and we stick to that protocol and we do these attribution studies in a period of 1 to 2 to 3 weeks. So there are 8 steps broadly, but I won't be going into all the steps. So coming to the first step, which is the trigger. So this is taken care of by our partners from Red Cross, Red Crescent. And they have a methodology or a set of criteria that they follow. And this would be talked about in more detail by my colleague Julie today. And we also, so I'll let Julie cover that. Now, the next important step is how do we define the event? So we define the event by examining where the impacts were. And so these are some of the examples from our past studies. So this is the case for a humid heat wave that occurred early in April, May in South Asia. And in one of the domains over India, so the impacts, because this was a humid heat wave, the semi-arid regions were not affected. So we define our region so as to capture the impacts, and also masking out the regions where the impacts were not so much, and also masking out the hilly region. So you need a high homogeneous region. So these, and like for example, the second one is the case for a flood. So when it comes to a flood, the rainfalls, what is more important is what is the rainfall received over a river basin. So that is where most of the flooding happens. So then the event definition would be focused on a river basin rather than a bigger region. And similarly for a drought, a different definition. So we have definitions, and then once again drawing back to how how climate change can be proxied by the changes in global mean surface temperatures. We use this approach to condition our distributions, to sort of shift the distribution to the world that we live in, which is the current climate or the 2023 years climate, and a world that would have been the pre-industrial climate when we had not warmed the atmosphere. So that is 1.2, that world would have been 1.2 degrees Celsius cooler than now. So we extrapolate the observations to see what would be the estimate for an event in a world without climate change. And this is a cool video developed by a comms team. So basically, this is what I'm trying to say. So there are some observations. And so this is for the case of temperature. So the hotter the event is, the more, is there a way to, sorry, I should have been able to do that in my, okay, let me just go back again. I'll just start with an explanation of what the axes are. Sorry. So this is what is called a return period plot. So what this conveys to us is what is the chances of, or the probability of a temperature, of any variable, let's say in this case temperatures, in the world that we live in, and in a 1.2 degrees Celsius cooler climate. So this would be the observed value, like let's say a temperature of 34 degrees Celsius. And what this essentially means is that this 35 degrees Celsius is about a 1 in 500 year event now, and it would have been much rarer in the past. So it's going to infinity in this case, but maybe this was not the best example now thinking about it. I'm sorry, but I hope I was able to make my point. But yeah, essentially, so there are some observations. And the hotter the event is, the rarer it will become. So this is the 2023 heat wave over the Mediterranean region in April 20, in the last days of April. These were how the observations looked in terms of the return periods. Now, in the climate that we live in, this is what the return period of that event would be, which is a 1 in 100 year event. And in a cooler climate, it would be something different. So it's not touching that line. So the conclusion here is that the 2023 event is a 1 in 400 year event in the current climate, and it has been made much more rarer due to climate change, and therefore it is 100 times more. And like you can quantify it by dividing the current probability by the past probability, you're able to put a number to it. And that is how we do this. And of course, so we don't just simply use observations alone. We also use climate models to evaluate how it looks in terms of the models and the observations, and then we combine everything together to provide an overarching result. So this is essentially what our final figure looks like. I won't go into the details, but what I'm trying to show here is that a probability ratio of 1. So if the probability, the chances of seeing an event in the current climate and the same event in the past, if it is the same, then essentially it would mean that there is no evidence of climate change, or we do not have enough evidence for climate change. Whereas if it is greater than 1 and statistically significant, again, sorry about the jargon, but if it is greater than 1, it means that it has been made more likely due to climate change, and if it is less than 1, it means it has been made less likely due to climate change. Now, and similarly, for we can also talk about intensity. So whether by how much degree, has it been made 2 degrees Celsius hotter or 3 degrees Celsius cooler, or no change. So essentially, that's how it translates. This is just another example. And then when we talk about an impact, and when we talk about an event, and when we talk about its impacts, the impacts will not be driven only by climate change. We can see whether there is a climate change signal, and that is an important factor. But then it is often also exacerbated by what are the vulnerability exposure components that contribute to it. And this, again, is led by our Red Cross, Red Crescent partners, and Julie would be talking about this in a little more detail. And then, once we have all our findings, once we have all our analysis done and our results put together, we communicate it in terms of a full scientific report. So this scientific report would have both the hazard, the attribution part, as well as a take on what the vulnerability and exposure factors were at the time of the event. And this is important to inform our stakeholders, inform the general audience about what we can expect going forward, and not only in terms of the number of events or the chances of seeing such events in the future, but what it would also mean in terms of adapting. And so to make it a little more easier, then we summarize the main findings together, and we put together as a web summary in addition to the full report. And then we also hold put out a press release, and we hold a briefing session where the journalists can come together and they can ask questions about the report. And I think again, Leo and there's Sam here, so they are in charge of our comms team, and they are a go-to people to know more about how we do, how you can sign up for the comms. But essentially, we have an email ID, and we also have a Twitter handle. So we just put some details here, but we can definitely ask me later. And yeah, and just to give you an example of how our communication looks like, we can say whether the event was made more likely due to climate change, or could be that it did not alter the likelihood, or climate change did not alter the likelihood, sorry. And there are also cases where we do not have enough data to, state whether climate change did play a role or not. So that is also an important aspect. Sometimes we are limited in our analysis because we do not have sufficient data in a region. And of course, there's the vulnerability and exposure component also. So we highlight that also where it is necessary. And some of these studies later on make their way into the peer-reviewed journal. So some of the studies we highlight, like depending on, there might be requests from our local collaborators that, we need more attribution studies in this region, and maybe we can put these reports through peer review. So we do that also, and these are some of our recent studies that were published. And I'm sorry, I know it's not very clear from there, but yeah, just wanted to show that. And just to, before I conclude, we also have a journalist guide that was developed by Dr. Freddie Otto and Ben Clark. Yes, and these are available, this is available in English and a few other languages as well, I'm not sure. But yes, so again, Leo and Sam would be your people to go to about this. And this is our website. This website, in our website, we have all the methodologies and everything explained in, in the short form. And for those of you who want to read it in the long form, we do have our peer-reviewed technical papers as well. And with that, I'll stop. Thank you very much.
So for those who have been around before with some attribution, you see it's still how we can go in and toggle this world, right? Raise levels of carbon dioxide, lower levels of carbon dioxide, and see, can you even recreate this event? And if you could, and one of the key communication points with attribution science, and this is where it gets a little tricky, though, but it doesn't mean that we wouldn't have weather events without climate change. We would have them. It's how much stronger are they, or how much wetter are they, or how much more frequently are they happening. So it's really looking at what climate change has done to an event that would already happen. And so thank you for the resources too. As you said, the journalist guide is fantastic, and we're gonna get into more of that with Leo. Leo, will you have the email for them to sign up? Did he just walk away? There he is. Okay, so he'll have the email so you can sign up to get on their press list. They do embargo for all of their events, and then they do have a press briefing for all of their events too, so you can get on that list. One thing I want to ask you before we move on to Julie, we all just went through a crazy past couple of months. Northern Hemisphere summer, but even on the Southern Hemisphere, just wild heat. What stood out most to you and your team during that time? I mean, what were you seeing in the data, or what shocked you, or what did you take away from that?
Well, the temperatures were anomalously high, as was expected. But more importantly, for us, it is the impacts. So when you talk about heat waves or floods, it is an important trigger that, or rather, trigger itself is framed on the fact of how people were impacted. So looking at the data, yes, the temperatures were anomalously high, the trends were there, and we had put out numbers based on what we could analyze with the available models and the observed records.
I just know in our office, we just kept saying, wow, wow, wow. I mean, it was just, whew. So, all right, now we're going to bring up Julie.